So let us understand the 3GPP specifications that define the 5G new radio protocol stack from physical layer up to the control and signaling layers. So understanding these specifications is critical for engineers, researchers and implementers working in the 5G ecosystem. So the physical layer 1 of 5G-NR is standardized primarily in TS 38.2XX series. So the 38.201, that is basically the physical layer general description. This is an entry point of understanding 5 layer, defines basically the duplexing. Then it defines the supported frequency ranges FR1 and FR2. Then also it gives us the bandwidth and the numerology options over there. And also it provides the reference architecture. So this is the highlight of 38.201. So when it comes to the 23.202, it basically gives us the procedures of the 5G systems over there. And the major one, that is 38.211, which basically gives us the physical channels and modulation schemes, wherein it defines the different modulation schemes over here, that is QPSK, 16 QAM, 64 QAM, and 256 QAM as such. Then we are going to have the next one, that is 38.212, which is basically gives us the multiplexing and channel coding schemes. So this basically covers the logical to transport channel mapping, then it talks about the LD channel coding schemes such as LDPC for data and polar codes for control signals. And we are going to also have the CRC, that is cyclic redundancy check, segmentation and rate matching being discussed over here. And also we are going to have a code block for groups and HARQ feedback. Then 38.213, basically it gives us the understanding on physical layer procedures for controlling. So over here, this includes the scheduling procedure, so it gives us the scheduling procedure for the DL and EL grants. It gives us the random access and beam management, and also it gives us the power control, and it gives us the timing alignment, and also the HARQ timings. So next is 38.214, that is basically the physical layer procedure for data. Over here it basically focuses on link adaptation. Then it goes to the focus will be on the resource allocation and also the HARQ operation, wherein we'll be able to understand the number of processes, soft combining and other things. And also it gives us the MIMO schemes and pre-coding options. The next one, that is 38.215, basically focuses on the reference signal received power, that is what we call as RSRP, and also it gives us the RSRQ. And then it is also giving us other measurement definitions such as SINR, CQI, and also the SSB for RSRP, RSRQ, and SINR. And also it gives us the measurement models and accuracy requirements. So these are the collective specifications that define how radio link is established and maintained and optimized in the 5G file layer. Then coming on to layer 2, which is the combination of the three different sub-layers, that is the MAC plus the RLC plus the PDCP over here. So MAC is medium access control. Then we are going to have a RLC, that is a radio link control. Then we are going to have a PDCP, which is packet data convergence protocol. So these are the major things. And for the 38.321, which gives us the understanding of MAC layer protocol specification, which primarily gives us the understanding of scheduling, that is for both UV and GNB coordination, then the HARQ operation, then we are going to have a logical channel prioritization, random access procedure, and discontinuous reception, that is what we call as a DRX over here, and also the uplink grant and buffer status reporting. So this all comes under the MAC layer. Then coming on to the 38.322, that is we are going to have a RLC supporting three modules over there, that is three modes over there, that is TM, transparent mode, unacknowledgement mode, and the acknowledgement mode. This document also gives us the segmentation reassembly and also talks about the ARQ in the AM mode. And also it gives us the error correction and retransmission over there. So the next one, that is 38.3223, that is the packet data convergence protocol, where the PDCP handles header compression, what we call as a ROHC, then the ciphering and integrity protection is going to be there, and we are going to have a in-sequence delivery and PDCP duplication for reliability, and we are going to have a handover support with PDCP recording. So the layer 2 overall, it is going to give us over here the layer 2 overall, we can say that it is going to ensure the link reliability, robustness, and also the efficient use of radio resources. Whereas 38.331 is going to focus on radio resource control, that is layer 3, wherein RRC, we can say that it is a brain of UV GNB interaction. So it is going to manage the UV states. So in the UV states, you are going to have ideal state, connected state, and inactive state. Then it is going to discuss on the radio bearer configuration. Then it is going to give us the understanding of cell selection and reselection. It gives us the understanding on the beam management and measurement reporting. It gives us the light on the paging and SIB information, that is system information broadcast. It also gives us the handover mechanism, mobility control. It also gives us the security key management. So we are also having the one more which has been not listed here, that is 24.501, that is non-access datum between UE and 5G core, which is going to handle the authentication and security, mobility registration and deregistration, PDU session management, service request and rejection causes. So the NAS message travel via the RRC and act as an interface between UE and 5GC. So that is in the 5GC, the AMF and SMF. So continuing with this, we have a set of confirmation, performance and test specification wherein we'll be looking into once the protocol stack is implemented. So we need to do the conformance testing and ensure it behaves as expected. Results are going to be obtained and it is going to follow the 3GPP standards, and some predominant ones we are going to discuss over here, that is 38.5211, that is wherein the 38.521 is going to discuss about the FR1 and FR2, that is a radio conformance testing, which is going to define the test cases for the RF performance. Then it is going to give us the transmit power, then also the EVM. Then it is going to give us the receiver sensitivity. Then it is going to give us the over-the-air test, what we call as the OTA test. So the other major important conformance test document, that is the 38.523, wherein we'll be able to understand the protocol conformance testing. So we'll be able to do the protocol conformance testing. Over here we can observe that it is a UV conformance specification for the protocol conformance specification test, and then we are going to have a part 2 of this, that is UV conformance testing specification, wherein we will be doing the implementation conformance statement ICS performance specification. Then we are going to have 38.523, which is UV conformance specification over here for the test suits we'll be having. So these three together are going to be, we can say that it is 38.523, which is basically going to cover the RRC signaling procedures. Then we are going to have a mobility bearer setup and SIP decoding over here. Then we are going to have a timer behavior and error handling also being discussed in these documents. Then we can also look upon one more document that is very important, is the 38.533, which is the RRM conformance testing. So this is the one which is going to give us the cell selection and reselection, handover performance, and the beam management accuracy. So to wrap up the 3GPP specification on the whole, we can say that the 3GPP specifications are not just theoretical documents, but they are the guiding tool for a real-world development, wherein each chip, base station, and a mobile device must follow these specs to ensure the global interoperability. So understanding these layers give us a clear overview of how 5G is going to work, the ability to debug and optimize performance, and the confidence to work on the cutting edge 5G development and research.